Advanced Python tips that you really need to know to up your Python game. And before I get started on that, I'd just like to tell you about this new course I've created. So if you navigate to flamethrower.ai in your browser, you'll get to my homepage. And if you're into machine learning at all, or just want to learn more about Python, in addition to machine learning methods, I created this course. It's really unique in that you get to learn how to build your own deep learning library, very similar to PyTorch and TensorFlow, completely from scratch. You'll write all the code from the ground up and then use it in your own projects to train your own models. And it's a really exciting course because you're not just like learning about something and then using it without really understanding how it works. Because you're implementing all of these methods from scratch, really it ingrains it in your head how all these things work, and it's cool to see how it's built. So go ahead and if you're interested, the course is $40 a month, and actually if you sign up you get membership to all future courses, access to all future courses that we create on the platform. And for the first 25 takers who email me at hello@flamethrower.ai. I'll put that email down in the description, but if you email me at that email address with the subject line, give me 25% off. The first 25 people who do that, I'll give you a coupon code to get this course and future courses for 25% off. So if you're interested, that's there. But now let's get back to Python. So here are the 5 things I'm going to teach you about today that a lot of people, it's advanced functionality that a lot of people don't know that Python has this to offer. And this is specifically Python 3. Some of these things aren't available in Python 2. But the first thing are generics and type annotations. Second is magic methods, and some of them have what we call right-hand side counterparts, so I'm going to be talking to you about those. I'm actually going to show you property decorators and how you can use them to create getter and setter methods for private class attributes. And then we're going to be talking about format strings, and then finally the slots attribute for classes. So there's a lot to go over here. Let's get started. So to sort of showcase all this functionality, I just created a fun little demo here. I'll also link this file in the description. But go ahead, try and implement it on your own. You'll learn it better that way. But let's see how this works. So starting with generics and type annotations, that's something that Python 3 provides. So I believe this is only available in Python 3. You won't be able to use it in Python 2, but you should upgrade to Python 3 anyway, because Python 2 is getting phased out of the ecosystem. Now, generics and type annotations are something that's offered in most object-oriented programming languages, definitely the compiled ones like Java and C++ and things of that nature. But basically a generic allows you to specify a type for the class, so you can specify what the type the class will have, but you don't have to specifically specify that type in advance. So the actual type is generic, but it ensures that that class only uses that one type. So if that's unclear, let's see how it works below. So to create a generic in Python, you use something called a type var, which you can import from the built-in typing library. And then you create it by saying something like t equals type var, and you give it a name, and we gave it the name t. Now, if you look at this wood class, or wood chipper, class that I created, it has you can see that it takes in as its parent generic of t. So it inherits from this generic class. And what that does is it tells Python that this class is going to use this single t type. And then you can use that t type in your type annotations for the class. So the wood chipper takes in three things. It takes in a list of twigs. And here we're using a placeholder for that type as t. And so, theoretically it could be something other than a twig, but we're going to do our example as if they are twigs. So it's going to take in a list of twigs. And to think of an example where it might be something other, like let's say a wood chipper could also chip branches or something. So maybe for a different instantiation of this class, you want to implement a wood chipper that chips branches or something. So that could be also a different type that you use for the generic. But this one we're doing twigs. And then name, which we're specifying it has to be a string. And then this keyword argument called other chippable things, which is its default is none. And so these are the type annotations. So to use a type annotation, you just state your argument, put a colon, and then write what type it's supposed to be. And then here at the end of the function definition, you can write an arrow sign, and then this is supposed to be the return type that the function returns. So this is just the init method, so it's going to return none. And let's see what else. So yeah, for some of these things, you're going to need to import their corresponding class from the typing library. So if you want to specify, we're specifying here that twigs is a list of this type t. So we need this list object from the typing library in order to do that. So then in our init method, we assign these variables. So here we're assigning quote unquote private variables. And there is really no such thing in Python as private or public class variables. Python doesn't enforce access levels, but you can sort of imitate that functionality in Python. And the way to do that that's typically done is you preface the variable name with an underscore, and that's supposed to indicate to the user of the class that it's private. So how do we get and set private methods? This is tip number 2. Well, the way we do it in Python is we use this property decorator. So this is a built-in Python thing. You would just write @property above the setter, or the getter function name. So this defines a property called twigs, and we say it returns a list of type t, and then it will return that hidden list, that private list, self._twigs. Similarly, we can do the same thing for name. Now, we won't want to change after the fact the twigs that are passed into the wood chipper, but let's say we want to rename it, like it goes into wood chipping battle and earns some honors, and we want to give it an honorary title or something. So to do that, we have to define a setter method for this private variable _name. So to do that, we just call the decorator name.setter, and then we define its function here. So it will take in a new name and reassign that name to this private variable. So that's how you do getter and setter methods in Python with the property decorator and the setter decorator. All right, so moving on. What was our third thing we were going to talk about? Yeah, magic methods and their right-hand side counterparts. So in Python for classes, you have these things called magic methods, and there are a number of them. You can look all of them up in the Python documentation. Each one implements a specific functionality for the class. But one thing they're really useful for is defining different types of arithmetic on your own custom objects. So let's say we wanted to add 2 wood chippers. How would we do that? Well, let's say our definition of adding one wood chipper to another wood chipper is that we take the twigs in the second wood chipper and add them to the twigs in the first wood chipper, and then we just return that first wood chipper. So that's what we're doing here. So now, if you were to do wood chipper 1 plus wood chipper 2, it would implement that functionality. Now there's a right-hand side counterpart to that method. So let's say that you were to do something like, let's say you wanted to add a twig to a wood chipper. So if you go up here and look at the twigs class, you'll see that it doesn't have an add method implemented. So when Python encounters something like twig plus wood chipper, at first it doesn't know what to do because it will try and call twig.add wood chipper, but twig doesn't have the add method. So in that case, before actually throwing an error, it will think, okay, maybe wood chipper has an add method. So in that case, it will actually jump to this radd magic method because wood chipper is to the right of twig, and it will call wood chipper dot radd of twig. And in our case, what we're going to do is we're going to take the twig, append it to the wood chipper's list of twigs that it can chip, and then just return the wood chipper. And then, of course, for fun, we implemented this chip method. So what the chip method does is it just consumes all the wood chipper's twigs, chips them up into a million little pieces. So the wood chipper no longer has any twigs. It gets set to an empty list. And then we print that the wood chipper's twigs have all been chipped. So this is tip number 4. This is what's called a format string in Python. And what it is you can just insert Python objects or names or strings into a pre-formatted string without doing like string addition, or if you've used Python before, you may have seen strings like this, %s. This is like a C style format string, so this is supposed to be a string. And then it would have something here like ha, and then %self.name. That would be an equivalent way of implementing this string's functionality. But this is like the newest Python way of doing string formatting, and I think it's personally the easiest. So you just put an F in front of the string, and then any like native Python code you put inside these braces, and it'll just insert self.name right into that position of the string. So that is the 4th advanced Python tip that I'm going to give you. The final one is this slots thing. So most classes in Python store their attributes in an underlying dictionary. So let me show you that here. So I created a couple of instances here of our objects. So, and I didn't fully introduce the twig object. The twig just takes in a tree type. So this is like the tree that the twig is coming from, and it stores that as a property. So let's see what the tree has. So we created a twig 1, that's a twig from a pine tree. Twig 2 is a twig from a maple tree. Twig 3 is a twig from a spruce tree. And 4 and 5 are from evergreen and fern trees, respectively. So let's just take a look at one of those. So twig 1, it tells you it's a twig object, and then it has this magic attribute called dict, which is the underlying dictionary that stores the class's attributes. So you see we have a mapping here from the private variable tree to the attribute name pine. Similarly for twig 2, that one was a maple tree, okay? So that's how the normal attributes are stored in Python. Now we can override that functionality using something called slots. So if we look at one of the wood chippers we defined, so I created this one, wood chipper 1, which holds the first 3 twigs, and I named it big wood chipper. So if I try and do big or wood chipper 1 dot dictionary, it's going to throw me an error. So slots overrides the underlying dictionary in the object. So let's instead take a look at slots. So slots is just a list that holds the allowable attributes for the class. So you have to, when you use slots, you have to define all of the attributes that are going to be used in the class ahead of time. And what this does is it saves on memory and performance when you use the object. So let's say you were going to create 1,000,000 wood chippers. You'll actually end up saving a lot of memory in Python, and your class will be more high performant if you use slots, because when you use this the standard way, which is to use dictionaries, Python is actually keeping a lot of overhead in there to be able to modify this dictionary. So I can assign new attributes to a twig dynamically. So I can give a twig like a branch. So I could do something like this. And now if I look at the underlying dictionary of twig 1, you'll see the branch has been added in there. But if I try and do that to the wood chipper, so if I do wood chipper 1 dot branches and just assign it an empty list, it's going to throw me an error because that attribute branches was not defined in the slots method, or sorry, the slots assignment. So basically what slots does is it gives you better performance for large classes or classes that you're going to be instantiating many times at the expense of some interactivity and like dynamic updating. So you can't like dynamically add new attributes to a class that's been defined using slots, but that's not always what you want. So it's a trade-off between the performance of the class and how dynamic it is. So those are the 5 advanced Python tips and tricks that you may not have known about. And before I finish off, I'll just show you them in action. So I showed you how slots works. Next, let me show you how the magic methods work. So remember, we had 2 wood chippers defined, wood chipper 1. So let's look at its twigs. And then wood chipper 2, let's look at its twigs. Wood chipper 1 has 3 twigs, if you remember from here. The pine, maple, and the spruce, and wood chipper has 2, the evergreen and the fern, which is what you're seeing here. Now, and we could show that, like we could say for x in wood chipper 1 dot twigs, print x dot tree. Okay, and then similarly for wood chipper 2. Okay, there you go. And now let's say we want to add wood chipper 1 to wood chipper 2. Well, since we implemented that add magic method, we can just do this using the regular addition sign in Python. So when Python encounters the regular addition sign here, along with these two objects, it'll recognize that they're both wood chippers and call the underlying magic method. So it returns wood chipper 1, and now let's look at wood chipper 1's twigs for x in So now you'll see all of those twigs have been added to wood chipper 1. And now let's see, what else do we do? Yeah, so we used the twigs property. So you'll see it was accessing the private variable twigs, but without that underscore. That's because we defined the property here. And it's using these type annotations. Now, one thing I'll say about the type annotations is that this is more just for the user of the code. So the user knows what types are supposed to be used as arguments to the class. The Python interpreter doesn't actually enforce this. If I go back to the documentation here, you'll see that. So the Python runtime does not enforce function and variable type annotations, but there are third-party tools you can use, such as type checkers, to do that enforcement. So that's just one thing to keep in mind. But yeah, and let's see. So the last thing I'll demonstrate, was there anything else? Nope, that was about it. So the last thing I'll demonstrate is how this format string works. So it gets called in the chip method, and then I wrote this function run all wood chippers. It takes in an iterable of twig wood chippers, and it basically just calls woodchipper.chip for each of the wood chippers in there. So let's do that. So let's just try run all wood chippers, and then I'll give it a list with wood chipper 1 and wood chipper 2. And you'll see it chipped both of their twigs. Now let's change wood chipper 1's name. And remember, this is using the setter decorator. So this is demonstrating that. And you'll see it worked. And now let's run all wood chippers again. And you'll see now the name has changed. So Hubba Bubba's twigs have all been chipped. And then small wood chipper's twigs have also all been chipped. So those are the five advanced Python tips that will really help you up your Python game. So I hope you enjoyed this video. If you want to learn more about Python, or especially machine learning, I'm going to be doing a lot of machine learning instruction on this channel. So hit the subscribe button. And also, if you're feeling like investing in your education, check out that Flamethrower AI course, and remember to send me an email to get that discount. And I'll have all the information, the description of the video down below. All right, it was great teaching you guys tonight, and I'll see you for the next one.